So this is going to focus on instrumenting and monitoring in Erlang. Been working with Erlang for about 7-8 years. My journey started back, and I learned Erlang from Francesco in Sweden, going to university, and started going to the Codebeam. I think back in that day it was called like Erlang Factory, Stockholm, and then sort of moved to the United States and started coming here to the SF one. So I've seen a lot of kind of transformations and different Erlang architectures over the years, and I realized that one thing that every Erlang developer at some point will have to encounter is instrumenting and monitoring. And so I want to provide this isn't like a systematic review, it's a kind of opinionated walkthrough of what a really high value approach to instrumenting and monitoring in Erlang would look like today with the minimal effort using some open source tooling. So we'll just walk through this presentation from a high level view and dive into how you can look at trends and how you can look into even like specific requests and how long parts of those requests take. So I don't know if you've ever, hopefully everyone's gotten the questions, why is something slow? You know, maybe like the CEO comes to you, customer comes to you and says like, my app is really slow, or the website seems really slow, or someone asks like, why is this, maybe they don't even see why are the requests failing. They're like, why doesn't anything load? Why does it just show some random error? And you know, you're sitting there and with your Erlang system, and so you need to start kind of thinking through, okay, how do I figure out what happened in the system? So you might start by asking like, okay, you know, who is this? Is this you that had the issue? Is this like a friend? Is this a customer? What were they doing? Were they like accessing maybe a checkout service in the system? Were they trying to look at their friends list? Were they trying to send a message? So that context can help a lot when you're mapping that into the architecture of your system. You can even go on and think about like, okay, where were they? Were they like 10 floors underground in a secure building? Or were they, you know, outside? Is it a busy area? Were they on LTE? Were they on Wi-Fi? There's a lot of other factors that you might want to take into consideration. And then just knowing, maybe they just were generally trying to do something, and that can even lead you in the direction of how they were trying to use your system. So all this context can help you get a high-level view. You know, this is an example. This is a picture from a lookout tower. So you can imagine, you know, your Erlang system is kind of like a forest. You're going to walk around and check on the individual tree health every once in a while. You're going to probably check do a survey of the forest health. But when you're really instrumenting and monitoring the system, you want to have a good high-level view. So if a fire, you know, kind of starts off in the distance, you'll be able to detect that and take action. So how do we get that high-level view? One option is there's some dashboards which you can get. This is backed with Prometheus, just VM metrics. You can get this for free when you add Prometheus, and you put it as a data source in Grafana. It has a lot of sort of the most important metrics for your Erlang VM. I'll walk you through some examples. This is open source, so you can go to this URL from Dead Trickster, and it's one of a few. This is probably the main one you'd want to use. So one of the graphs here, looking at VM memory, maybe the issue happened around like 304, 305-ish, someone says to you. In this case, it looks like, you know, the service didn't actually crash, but you can imagine that sometimes memory could even jump so much that your node runs out of memory. Maybe there's so many requests coming into your system, or there's binary that's not getting deallocated. In this case, we can see the binary memory jumped a lot, atom memory jumped a little bit, and we can look into our system then with that context and know, okay, what was happening more in the system which could have increased the memory usage. Another example, just processes running in the system. You know, Erlang is wonderful at handling lots and lots of processes, but when you have too many processes running and they're just not getting allocated to schedulers, you can see that there's going to be spikes in the run queue. If that run queue length just really takes off, that's a concern. If it's a little bit spiky, it's probably okay, but that can also be something where you have to maybe think in your system how you're going to handle the throughput, and not kind of max out your processes in the system. Just for context, like each, Erlang is a little bit different. It's preemptively scheduled, so it'll switch between processes, and so every time it uses up, it has like the unit of reductions. Once it reaches 2,000 reductions, it'll trigger a context switch. Context switches are okay, but if it's happening constantly, your system won't have the throughput as much as it could have, and so maybe you want to also look at slowness. Context switches could be a sign of load, or just a load that your system wasn't expecting as well. So these are just some example graphs. You get this for free. There's just a JSON payload. You have to pop into your Grafana, and you have this great dashboard with a lot of metrics. So there's a little bit you have to do in Erlang, and this is assuming you have your Erlang node running on a Cowboy server. There's also flows for how you can set this up for other web servers. I've just found Cowboy to be a very common web server used in Erlang. So I'm just going to walk you through this. There's a little bit of there's always a little bit of process getting things hooked up in Erlang. So this is in the web server app file. You're going to start by instrumenting and setting up different metrics. In order to record data for those metrics, you're going to create them so that they can start accumulating data. Then you're going to add an endpoint. Just for context, Prometheus, you can do, it's like a pull-based metric system. So you're going to actually expose an endpoint that your Prometheus server is going to pull the metrics off the server from. And then third, you need to also include some callbacks. So, Cowboy has a number of modules it'll call back through as you receive a request, and you're going to want to include a callback so that when it receives requests, it can include different tracing things, or it can collect data. And I'll talk about that in a little bit. You also need to include, these are hex packages, so I'm going to assume you're using Rebar 3, so it's really wonderful. You can just pop those in, lock it at the latest version, and you have to include those also in your app source file, so that it starts up when your application starts up. So the first tool I want to talk about is Prometheus. Prometheus is great at giving you data about trends in your system, like what's my average response time, what's the average payload upload time to my server, things like that. So Prometheus it's not a tool written in Erlang. So you just have to give it a little configuration and pass in this YAML file. You don't even have to necessarily add the scrape interval. I just modified it to 15 seconds. I think it's a minute by default. You tell it what you're monitoring. So you could put the name of your release in there, like I don't know, chat service or web host, and then you would tell it where it should scrape from. And you can dynamically configure this. So this could be a dynamic list of all your hosts that it's going to be scraping data off of. In this case, I'm just running locally, so it can pull it off there. All right, and then you just run it. It's as simple as just Prometheus and passing in this YAML file. All right, so what do we get for free? I mean, we just included a library. We added some function calls, some callbacks into our web server. Not only are we going to get all these VM metrics that let us make that dashboard, but we're also going to get metrics around our web server in terms of errors it has, the amount of protocol upgrades it does, how many processes it's spawning with each request, and like how long requests are taking, and just errors in general. Let's say you want to break that down because you want to know, like, for example, okay, who's making these requests? Maybe you have a malicious host and you just want to get an idea of what kind of requests that malicious host is making. You can even, these library hooks you add into your web server, they'll actually add tags that allow you to filter requests based on the host name, what kind of status code there was, even error messages or error types in your system. The part where it gets a little bit complicated is adding path. The libraries leave it up to you to include path because everyone does paths a little bit differently. So I don't know. Let's just imagine you have like some user/user ID endpoint. You want to be able to just abstract that user ID so you can filter all your user requests under one path. In the example I'm going to give you, I'm actually just adding some paths in for as an example. So here's an example. This is like the most basic aggregation query. This is just running what's my average request time over time on a 5-minute basis. So inside of Prometheus itself, you can already start accessing metrics and seeing that it works. All right, so that's sort of at the high level trend level. We're looking at VM metrics. We looked at request response time. Now we're going to look into OpenCensus. OpenCensus is using spans, so you can you can inspect into your system exactly how long each step of the process is taking. This is just a very basic example. You have a client making a request, then the server is reaching out to, let's say, an external API, and then it's reaching out to your database, and then it's updating your database, and then it's responding. So it's just a simple synchronous request with 3 major steps. And let's say you had a report that someone experienced a very slow request response time, but you're not really sure, like, is that because my database is slow? Is that because like external services are slow and so on? And so this will help provide you insight into that. So this is an example. This is just running in Zipkin. You can see in this case, the external API to check authentication took a long time. It's kind of like a flame graph in that you have at the top, you have your overall span. This is a really easy way to name spans. You can name them after just module functionality. And you can add tags to these as well. So in this case, it's just a handler that you're getting something from the server. It's reaching out to an external API. It's getting something from the database, or let's say it's even making another request to an external service and then updating the user. So that's just like a very, very basic example, and it can get much more complex with like microservices and so on. But the essential idea behind OpenCensus is that anything that you want to measure, generally, you just need to start a span and finish a span once you're done with what you want to measure. So if you want to add metrics around your database calls, you just need to add a start and a finish before your database calls if you have an external API request start and finish around that API call. All right, so let's say we want to have microservices. This is where it gets a little bit more complicated. There's like a bridge that you have to intercept the span from, include it in your system, and then add children's spans to that. So let's say we had our service here. It reaches out to another service. It'll include something in the header, and then that header will get used to then record child spans, and then it'll get passed back, and then it'll continue on creating spans potentially in that previous microservice. This is something that you get for free with the stuff I showed you before. The only thing that you have to implement is that you need to include the header when you're making requests to other services, so they can also ingest that header and use it to keep track of spans. So this is just an example of something more complex. So in this case, we have this is our let's pretend like this is our original service. We reached out to another endpoint where it has its own set of computation it's doing, and we can see that header was just passed through to the other service. So this is all in GitHub online, so you can just view it. You can download it. It's made to be a very simple example where you can get everything up and running in just a couple of minutes, hopefully. And it's all open source. This isn't something that's unavailable. This is something that hopefully is accessible. Maybe the documentation could be better. So I encourage anyone to open pull requests with documentation or different ways that you've used it and experiences. A kind of a caveat to OpenCensus, I know there's a migration plan to OpenTelemetry. Last I heard, like 6 months ago, that's going to be like a 2-year process. So but it will be backwards compatible. But just to keep an eye on OpenTelemetry, it's not stable yet. OpenCensus is stable. OpenTelemetry is not yet. So I would start with OpenCensus if you're starting now. If you're starting in a year and a half, then OpenTelemetry would probably be better. Yeah, so just try it. Share your experiences on open source so everyone else can benefit as well. This is something that everyone has to deal with as an Erlang developer. And I just want to finish off by saying, thank you to the RealReal for supporting this conference, and we're also recruiting. So if you want to take a picture of that QR code, it'll take you right into our job portal. And then also finally that all this code is on GitHub for you to access if you want. Thank you.
Do we have any questions?
Yep.
And it's getting close to lunchtime.
Hi, thanks. That was interesting. I just wanted a clarification about what you meant about a migration from OpenCensus to OpenTelemetry. Who's migrating? What do you mean by that?
Okay, yeah. So from what I understand, the spans are getting, you can send it off to different services, whether that's Zipkin or Jaeger. And there's a certain API that there's a protocol, and it's sort of an open standard for that. They are merging 2 standards into one, and then ultimately it'll become OpenTelemetry. So they're working with backwards compatibility in mind, and so you'll be able to still use OpenCensus for some time with services that are relying on the OpenTelemetry protocol. So your work won't go to waste, but there will ultimately be a migration long term. I think just from looking at it, it's going to be very similar to how OpenCensus works, but just something to be aware of long term.
Thank you.
Probably have time for one last question.
So do you know anything about how this migration and or other things may interact with the push to get sort of a standardized telemetry system in, maybe not in the OTP, but as sort of the best class citizen of OTP? I think there's some effort going on. Do you know anything about that?
Yeah, I mean, it would be great if just the telemetry built into Erlang provides a lot of these metrics, and you can just integrate it with a lot of these open source tools. I don't know if it's there yet. But I think it's a lot of these tools are potentially built on top of that, so it could leverage that. But I think it's more of there'll probably be an overall process where the core libraries catch up with the tooling, but the tooling will always be a little bit ahead. And with these being tools, they're going to add more functionality kind of on top of that telemetry for you. Yeah.
Cool. I guess that wraps it up. I think it's time for lunch now.
All right.
Thank you very much,
Thank
Markus.
you.